733. This is chapter 7, homework, problem 33. It's a calculus plot problem, and it says a small block with mass equals 0.040000 kg is moving in the xy plane. The net force on the block is described by the potential energy function U sub xy equals 5.80 joules per meter to the fourth. Wait a minute. Meter squared per meter squared times x squared minus 3.60 joules per meter cubed times y cubed. Okay, what are the magnitude and direction of the acceleration of the block when it's at point x equals 0.300 meters and y equals 0.600 meters? All right, so we're looking for the force. So remember, F equals negative d, well, this is a partial, du dx, and F of y equals negative du dy. So going ahead and doing that, and acceleration is F equals ma, so acceleration is F over m. So let's go ahead and get us some board space and do that. All right, so F of x is going to be equal to negative 11.6 joules per meter squared times x. And F of y is going to equal to a positive, right? Because I already have the positive 10.8 joules per meter cubed times y squared. And solving for this, if I put instead of x, put 0.300 meters, and y, I'm going to put 0.600 meters quantity squared. I'm going to get f of x equals negative 3.48 newtons, and f of y equals positive 3.89 newtons, 3.89 newtons. And so to get my acceleration in the x direction, I've got negative 3.48 newtons divided by 0.0400 kgs, and that's going to give me negative 87 meters per second squared, negative 87 meters per second squared. And a sub y is going to be equal to 3.89 newtons, 3.89 newtons divided by 0.0400 kgs. A sub y is going to be positive 97.2 meters per second squared. Now, we always want to convert to polar, so let me get some board space. So we're going to have a equals square root of ax squared plus ay squared. A is going to be equal to the square root of negative 87 meters per second squared, quantity squared, plus 97.2 meters per second squared, quantity squared. And that's going to give me 130 meters per second squared. And then to find the angle, we're going to go tan inverse of 97.2 meters per second squared divided by negative 87 meters per second squared. And that's going to give me 48.2. And let's see, this is in, that's negative 48.2, but this is in the second quadrant. So if I take 180 minus 48.2, I'm going to get 132, roughly 132 degrees. Okay, and that was 7.33. Okay, now we're doing 738, which reads, two blocks with different masses are attached to each other to either end of a light rope that passes over a light frictionless pulley. System suspended from the ceiling. The masses are released from rest, and the more massive one starts to descend. After this block has descended 1.2 meters, its speed is 3 meters per second. If the total mass of the two blocks is 22 kilograms, what is the mass of each block? All right, so we're going to go ahead and do delta EK. Oh, I like this thickness, is equal to delta U. I don't really like it that much. Let's see. Let me go with the skinny one. All right. So delta EK is 1/2 MA plus MB times V squared equals MG times, I'm sorry. This is G. We'll call this HG. And we'll call the MA is the one descending, so it's losing potential energy. So it's MB minus MA. All right, we have that. And we also know that MA plus MB equals how much? 22 kilograms. All right. Okay, so we can go ahead and solve for MB. MB is going to equal to 22.0 kg minus MA. All right, so we have 1/2 times, we already know this is 22 kilograms, kg, times V squared, and we were given that value. That was 3 meters per second, 3.0 meters per second, quantity squared, equals, H is 1.2 meters, and G, 9.8 meters per second squared. And MB is going to be equal to 220 kg minus MA minus MA, so minus 2 MA. This is 220 kg minus 2 MA. Okay. And then solving for MA gives us 15.2 kgs. And then MB equals 22.0 kg minus 15.2. And that's going to be equal to 6.79 kg, 6.79 kg. That is the mass of B, MB. All right. All right, now we're doing 7.41, which reads, a 350 kilogram roller coaster starts from rest at point A, which is 25 meters up, and slides down a frictionless loop, the loop. How fast is the roller coaster moving at point B? Point B is 12. It does a whole bunch of gymnastics between there, and then point B is 12. But really, this is a conservative force, so it doesn't really matter what it does between those. And it's upside down here. It's going this way. All right, so 1/2 m delta v squared equals mg delta y. The m's can go. So v is going to equal to the square root of 2g delta y. And v equals the square root of 2 times 9.8 meters per second squared. Delta y is going to be 13 meters times 13.0 meters. And v is going to be equal to, I'm going to grab this from here, let's see, 16 meters per second, 0.0 meters per second. Now the normal force there, we did a problem like this a couple chapters ago, chapter 5. All right, so we know that n right here, n's going that way, mg's going that way, mv squared over r. N plus mg equals mv squared over r. Okay, so what do we have here? We've got, I want to know what the normal force is right there. N equals 350 kgs times v squared, and I just calculated that, didn't I? 16.0 meters per second, quantity squared. R is 6 meters over 6 meters minus 9.8 meters per second squared. Okay, so that's going to give me 1.15 times 10 to the 4th newtons. And that is how hard I'm pushing against the track there. The track is pushing against me the negative of that. 7.61 is a calculus problem. It reads the conservative force F is in the positive x direction and has magnitude F of x equals alpha, I guess divided by x plus x naught, quantity squared, where alpha equals 0.800 newtons times meters squared, and x naught equals 0.200 meters. What is the potential energy function U of x for this force? Okay. All right, so now we're going to take the integral of this. So F U equals negative the integral of negative f of x dx. So that would be just alpha over x plus x naught, right? Because -2, you get -1, that would take care of the negative. So let's see. Okay, so let's see. F of x equals du dx. So du equals f of x dx. And let's see, integrating both sides, we get, this is negative f of x. So we're going to get, this is just the same as alpha times x plus x0 to the negative 2. Integrating that, we're going to just get alpha times x plus x0 to the negative 1. That to the negative 1, right? And that's going to be equal to alpha over x plus x0. And that's fine. 7.61a is fine. That's all I'm going to hold you responsible for on this problem. Okay. That concludes chapter 7.